Today's section, we're going to talk about mixed quotients, so mixed fractions. There are two different ways of solving these problems, but the one method that solving the mixed quotients we went over when we did the division of rational expressions. So I'm going to just review one time. So this first method is realizing this divisions right here. This fractions, the larger fraction right here is same as divisions, right? So this problem you can rewrite as 1 over 2 plus 3 over x dividing by x plus 3 over 4. The reason I have a parenthesis to show that there is both term, right? Both term is on the numerator, dividing by denominator, which is just one fractions, right? So that way that you will do simplifying numerator first, because the order of operation, you do the parenthesis first, right? And then do the divisions. So because this is the first problem, I'm going to show you what we will do, realizing that large fraction is same as divisions, right? So we do the parenthesis first. Order to do addition, same denominator. So that will become 2x. 2 to become 2x, you need to multiply by x. It will be x plus 1 plus x to become 2x, you need to multiply by 2. So you're going to multiply 2 to the 3, you get 6. And because it's not like term, right, you cannot combine, but it's already one fractions. And then change division into multiplications, flip the second fractions. And get rid of the common factor. And then multiply. Right? This is what you do. And that's what we went over from dividing rational expressions. Here, since we wanted to talk about different method, right? I'm going to show you the other way of doing the same problem. And for me, this is the shorter version of it. But if you don't want it to go over the new way of doing it, you can keep doing it this method. This is what we did. So the way that I like to do, and it saves some time, I think, is if we have a same problem. This first method right here, let me write or. The first method right here is getting rid of this larger fractions, right? The second method is trying to get rid of this smaller fractions to get rid of complex. So then, in order to get rid of this smaller denominator, you need to find LCD of 2, 4, x, 4. So whatever that LCD you multiply numerator and denominator, you will get rid of this denominator, small denominator. So look like 2 and 4 common is 4 and x. So if you multiply numerator by 4x, denominator by 4x, if you want, you can think as 4x over 1. Numerator and denominator common can be reduced. So that will be 1. So there will be no more denominator, this denominator, right? And because this have two terms, multiply by one terms, you need to distribute. So you end up multiplying first fraction by 4x over 1 also, right? So then this will give you 2 cancel out. That will be another 1 on denominator. X cancel out. That will be 1. So no more denominator. So what's left over if you write it? Let's see. it will be 2 times 1 over 1 times 1, so it will be just 2. And then the second term on the numerator will be 3 times 4 over 1, right? And don't forget to write this x right here. Let me see. This x, right? So it will be not just 2, but it will be 2x. So this fractions become 2x plus 12. Now this one, you have x times x plus 3 remains. And if you factor the numerator, you get 2 times x plus 6. Denominator is already factor form. See? You will see these solutions and this solution is identical. So no matter which method you use, you end up getting the same solutions. I just wanted to show you there is more than one way of doing it, right? And you know, I think the second method is a little faster, but if you don't want it to learn the new way, then you can use changing the larger fraction into divisions. Just remember you need to parenthesis grouping notation if you have more than one term on one side of fractions. So because this method is something that we've been doing it in the dividing rational expressions, from now on, all this example, I will just try the second method. Because since you already know, and we went over this method from the other sections. So this one, let me see. I have how many small denominator? 1 and 2, right? But then this small denominator, you have the same thing. So basically what you need to multiply here to get rid of smaller denominator is x over 1. But because you have 2 term and denominator 2 term, when you distribute, you end up multiplying x over 1 to the 4 and this 4 also. And this denominator cancel out. So then what's left over? I will have 4x plus 2 and then 4x minus 2. And let's see if I can factor. Common factor 2. Then I have 2x plus 1. 2x minus 1. Again, I can get rid of common factor. Then I will have only 2x plus 1 over 2x minus 1 remains. Right? Don't forget you cannot get rid of this 2x first, this 2x, because why? It's followed by addition subtraction, which means this is not going to be factor. This is addition and subtractions. You can only get rid of common multiplications, not addition subtractions. Try one more. So this one right here, you have this denominator, this small denominator. So if you wanted to get rid of that, we need to find LCD of these two, right? So I'm going to look at x squared minus 4 is 2 squared. So that's going to be x minus 2, x plus 2. And then this small denominator, it's already there. So least common denominator of these two is x minus 2 times x plus 2. So that's what you're going to multiply on all four terms, right? Because you're multiplying at numerator and denominator and you have two terms you need to distribute. So let me write all that here. So you have x squared over x squared minus 4, but then you're going to multiply this by least common denominator, which is x minus 2 times x plus 2 over 1. And then minus 3, you're multiplying also x minus 2 times x plus 2 over 1. And that's what you're doing, just to the numerator. Now you have denominator, x minus 3 over x plus 2 minus 1. You're going to multiply least common denominator. On both. So then this will cancel out. And nothing else on this side because you don't have denominator, right? This one don't have denominator to reduce. So if you rewrite what you have so far, you have x plus, let me write the numerator first, right? So you will have x squared minus 3 times x minus 2 x plus 2. Denominator will be x plus 2 times x minus 3 minus 1 time x minus 2 x plus 2. Then simplify, right? We know this is equals to x squared minus 4, right? This is equals to x squared minus 4. So when you distribute negative 3 and negative 1, negative 3, negative 1, to open the parenthesis, you're going to get x squared minus 3x squared and plus 12 over, when you FOIL this, right? When you FOIL this, you're going to get x squared minus 5x plus 6. And then when you distribute this negative into this difference of square, you get negative x squared plus 4. Let's combine denominator. Wait, hold on. This is the like terms, so you can combine this two also, right? So let me erase that. And when you combine that, what do you get? Negative 2x squared. Combine denominator. Look like this two cancels out. Negative 5x. This 2 will be plus 10. Numerator, factor 2, negative 2 out, x squared minus 6 there. And denominator, factor negative 5 out, you will have x minus 2. And since you cannot factor any further and you don't have any common factor. That must be the solution for that problem. I am only going over in 3 examples from these sections, but if you have any other questions while you're doing your homework, please contact me by email or visiting my office hours, and we can go over and do more examples.